Welcome to Uiua for Complete Beginners number 7. So we're looking today at Advent of Code 2015 Day 2. The title is I Was Told There Would Be No Math. Not a very informative title. We're calculating how much wrapping paper is needed to wrap a present and how much ribbon is needed to wrap a present. The example given, if the dimensions are 2 by 3 by 4, then for the wrapping paper, we've got to find the surface area of that. So that's like, 2 lots of 3, 2 lots of 4, 3 lots of 4, and then double that. So 6 sides in total. So we get 52 from that. And then for extra wrapping paper, we get the area of the smallest side, which in this case is 2 by 3. So that's 6, and add these two to get 58. And for the ribbon calculation, we start with the shortest distance around the present. So if you can picture a 2 by 3 by 4 rectangular prism, the shortest distance is to get to use the 2 by 3 cross section. So you've got 2 plus 2 plus 3 plus 3 is 10. And then for ridiculous reasons, you add the volume. The volume of this is 24, and you sum those two values to get 34. The data has 1,000 presents in it, and you've got to work that all out. So if I read in my data, and here are the answers for my data. Okay, so this is what the data looks like. You can see all the new lines and stuff. This is what it's like in here. So I'm just going to use regular expressions to get every number out of here and then shape it into a 3 by whatever array. So let's try this. So read it in as a string, and then I'm going to call regex and then extract every digit out of there. So they're all in boxes. I want to call each, and I'm going to want to parse them. This is not going to work because you can't parse things that are in boxes. So I'm going to unbox. And now I've got a long, how long? A 3,000 array, a 3,000 length, one-dimensional array. So I'm going to reshape that into go -1 and 3. So basically, the -1 is not a legitimate length. So like a dimension. But the 3 is. So it's basically saying that the second axis is 3 and the first axis is however long it needs to be. And so now we've got a 1,000 rows and 3 columns. So that's our data. All right, so I've got my data. I'm going to use X as a sample, so we know what to expect from there. Okay, so the wrapping. Just setting up a function here. I know this looks ridiculous, but I just wanted to format to begin with. Okay, so, and I'm going to call the wrapping on X, and I want to see a value of 58. But of course, don't see anything like that just yet. Okay, now for the wrapping, all right, if I've got 2, 3, 4, I need to multiply 2 by 3, and I need to multiply 2 by 4, and I need to multiply 3 by 4. How do I do that? Well, bit of a rabbit hole here. So what I really want is to just bear with me a sec. I'm just going to give myself a separator, like I often like to do. That's because I need an equals. Okay. All right, so I've got a play area under the separator. All right, so I want to create that 2 by 3, 2 by 4, 3 by 4. How am I going to do that? What I really want is to kind of, I just think of it as a mask, right? 1, 1, 0. I want to select the first two elements. I want to select, say, the first and the last, and I want to select those, right? And then I want to, like for each of those, I want to use that as a mask. So if I say keep, for instance, 1, 1, 0, x, then I get the 2 and the 3, right? So I want to like apply keep that to x, and I want to apply keep that to x, and I want to apply keep that to x. And if this was another language that I'm familiar with, then this would be like done super quickly. And there is a good way to do it in Uiua. I just wasn't familiar and had to ask for help. So something that doesn't work is to say, now each is no good because that'll give you 9 elements. I want the rows. So if I take the row, well, this will work in a fashion. So if I take the row, then I get that, and I'll go keep, and I'll go that, and I want to keep it with x. Now that's not going to work because the arguments are in the wrong order. Right, so that's, but if I flip the stack, then I get exactly what I want. Okay, so I've got the 3 pairs that I want. Okay, but this is not like good because I'm mentioning the x, right? So whereas I want to iterate over this and have each of these put on the stack for me, right? And I need, well, sorry, let me just, okay, so I want each of these to be put on the stack, which they are. All right, but here I am mentioning x. Well, I want x to be a value on the stack. So for instance, okay, so I've got my source array 2, 3, 4. I've got these masks that I want to apply. Right, x is on the stack, the masks are on the stack. Now what? Like, I don't want to be mentioning x here, but this doesn't work. All right, so there's a function in Uiua. There's one called distribute and there's one called tribute. And the purpose of distribute and tribute, they're just the same thing but in reverse, is to apply each row, to apply a function to each row of an array along with another value. And so because my value is on the stack first, I'm almost certain I want tribute here. So tribute is modifier like rows. And now what function do I want to use? I want to say keep. And there we go. Right, see how it consumed. Right, that x is not there anymore. Right, if I get rid of that, right, so I had my 2, 3, 4, I had my masks, right, but now if I run tribute, then it consumes both of those things off the stack and produces the pairs, which is great because from here I'm able to do a row-wise multiplication. Okay, so 6, 8, and 12, and now I can do a sum, and then I can double, and that gets 52, right? Excuse me. And while I'm at it, what else did I need to do? I needed to do the minimum side area, like I need to do the area of the smallest side. What's the smallest side? How do I get the smallest side? Well, if I sort of undo some of my calculations here. Okay, so I get the two, so I definitely want to include this. Okay, here I have some areas, 6, 8 and 12. I need the smallest of those areas. And so that means I need to pop another copy of that on the stack, do these operations, right? And now I need to get the minimum from the 6, 8, 12. Well, what I can do is I'll do a dip. Geez, I love dip, right? Okay, that didn't work. And I know why it didn't work. Right, dip allows me to go to the second value, and I'm going to do reduce minimum, right? So now I see what happened there? Blink and you miss it, right? So I have on the stack, I've got 6, 8, 12, and then I've got the 52. What I want to do is change the 6, 8, 12 into the smallest of those values, which is just the 6. So I call dip and then reduce minimum, right? So it acts on the second stack value, not on the top stack value. And now I just need to add those and I get the answer. All right, now there's more to say about this. And that is, I don't like typing in these masks. So I want to generate the masks somehow. How am I going to generate the masks? So one thing I noticed is that they're actually like a rotation, right? So take a look at this. Right, so I've got 1, 1, 0. If I do rotate 1, then I've got 101. So it's been rotated to the left. And if I do rotate 2, then I get the remaining one, right? And if I do rotate 0, then I've got the original. So basically, I want to take 1, 1, 0 and rotate it each of 3 times. So I basically, I need to use distribute or tribute again. So that's, like I've got the 1, 1, 0. How about I take the range 3, so now I get 0, 1, 2. So basically I want to go 0, 1 and 2, like I want to apply rotate 0 to that, and rotate 1 to that, and rotate 2 to that, okay? So my fixed value is behind it on the stack, so I'm using tribute. And tribute, I'm going to rotate the value. Oh, that's it. Okay, so I don't need the brackets. I mean, I kind of knew I didn't need the brackets. So there you go. I've been able to produce rather than type in, because I'm not into that typing in. Okay, so I'm going to put this on one line. Okay, and this can go in here. All right, so 1, 1, 0, distribute each of those, and now what? And now, so the x, so I'm calling wrapping x, so x is on the stack here, okay, I'm not going to keep that, but x is on the stack. I've generated my, there it is, x is on the stack, I've generated my mask, and then, or my masks, and then the rest of this now just has to go in here. Oops. And there we go. My wrapping X answer here is 58, and I will get rid of all of that. There we go. All right, so maybe tidy this up a bit, like how would I like the lines to be? I've got that to begin with, keep that. Okay, so this just gets the pairs, right? This gets the pairs, this gets the sides. Yeah, I don't know. I'm not going to waste video time getting into tidying that up. All right, so that's the wrapping. I wonder. Let's see if what I get if I do the data. Oh dear. Okay. Sorry. That's because, of course, wrapping is designed to be called with one value, whereas data is many values. So to do this, I just basically going to say start with data, and then for each row, I'm going to call wrapping. Right, so I can do that. That gives me each one, and then I just need the sum of all of those. Okay, 1606483, and there's what I've already confirmed is the correct answer. Okay, so now what is ribbon? Right, so what do we need? The shortest distance around the present. Okay, now I've got my own notes here. I'm going to just be a bit more efficient here. So we're going to start with the volume. So the 234 is on the stack. I should be calling ribbon X to see as I go. So the volume is if I were just to calculate the volume, I'd do a reduced times. So that gives me 24, but now I've lost the thing that's on the stack, right? So I'll do that on a copy. Right. So I've got the original, my input, and I've got the volume, right? But now I'm going to flip those straight away, because like the volume is just to calculate, I'm just going to calculate later. I need to act on this, so I need this to be on the top of the stack. All right. Now I'm going to say plus the shortest distance around the sides. Okay, so the shortest distance around the side. So I've got the 2, 3, and 4. What I need is to sort them. Now, of course, they're sorted, but it's not going to always be the case. So I need to sort them. So the idiom for sort is select rise dot. So that's sorted. Of course, nothing changed. But if I don't do the select, then that gives me 0, 1, and 2, basically saying if you want to get a sorted array, take index 0, which is 2, then index 1, which is 3, then index 2, which is 4. Well, I want the smallest 2. So I'm actually going to just, if I just say I'm going to take 2 of rise, then I only get the 0 and 1, and then I'll call select. All right, so I get the 2 and 3. All right, so that's going to give me, so what if I, this doesn't change if I, okay, so if I can put X in a different order, it doesn't change any answer at all. So there we go. I've got the 2 and the 3. So the shortest distance around the sides, well, the 2 and 3, I just kind of need to, add them up and multiply by 2. Right, so that gives me the 10, and then I just need to add that. Okay, so 34, and rather than calling ribbon X, if I now go data and apply ribbon to each, and then take the sum. Okay, and that agrees with the answer I had before. Okay, now last thing before we end the video, back to wrapping and generating the generating this thing. So if I just take 2 lines there. All right. So I did all this work so that I didn't have to type this in, right? But notice I'm still typing this, right? And what I really want here is like give me every possible pair out of 3 things. But what if I wanted every possible pair out of 7 things? Like this rotation business just simply wouldn't cut it. So like back when I solved this a week ago or so, just haven't been able to make a video. It kind of bothered me thinking, oh, how would I get all the combinations? And I couldn't think of a way because if I was doing it in a different programming language, I'd use recursion, and we don't have recursion in Uiua. If I wasn't using recursion, I suppose I could use some kind of imperative approach. I've never written anything imperative in Uiua. So, yeah, I just kind of left it. And then I just happened to be mousing over some things in UiuaPad earlier tonight, and I saw the bits function, which I've never used. And so let's just see, what does bits do? Let's say if no, you need it wants an array. Well, what is, okay, there you go. You can call it, I mean, a single item is an array of rank 0. So it's given me a binary representation in reverse. Don't know why. Like I say, never used it before. And if you give it an array, like it's pervasive. So if I said 3, 8, and 12, okay, so here's binary 3 in reverse, here's binary 8 in reverse, and here's binary 12 in reverse. And so this gave me an idea a week later for how to find combinations. So let's build this up a bit at a time, right? So if I take a range, now if I want, let's say take range 8, right? Why 8? Because if there are 3 items, okay, if there are 3 items and I want the ones that have 2 things selected, well, every possible way of selecting things from 3 items is listed here. This is the power set basically, and why 8? It's 2 to the power of 3. So rather than doing 8, I'm going to say 2 to the power of. Now that gives me one more. I need to flip this to get back to where I was. The reason I'm doing it is because 3 is like our input, right? So anyway, I've got all these binary things. Well, now I just want to select the ones that are that have 2 ones in them. So if I do a row-wise addition, then you can see some of them have 2 and some have 1, and one has 3 and one has 0. And now I want to use those as indices, so I need to work with a copy of that. And then I just call keep. No, I don't. I must call select, I think. Or maybe I should think before opening my mouth. No, I definitely don't want keep. No, of course, I need to narrow this down to the ones that are equal to 2. Right? And so this is now given me a Boolean mask, and now I can say keep. Right, and so there you go. I've got my masks without typing in any kind of raw data, and without using rotate, which doesn't generalize. So if I wanted to get all of, like I said before, say all pairs of things when there are 7 items, then there you go. And now 2 to the power of 7 is 128. So the power set has 128 rows in it, but I've filtered it down to the ones that have 2 1s in them. So that's pretty cool, right? Now, it's a bit of an exponential time algorithm, but it's pretty cool nonetheless. Okay, so that was just a PS. Hope you got something out of this, or otherwise enjoyed the video.